In this video, we're going to take a look at how to integrate some disparate data using C#.NET and Visual Studio 2017. It's a bit of a unique case because what we're going to do is consume a JSON feed, and it will be this JSON feed right here, which is essentially a list of plants, genus, species, cultivar, and common name. And then we're going to apply some business logic, and we're going to activate all of this and output it using a web service. So there is going to be a little bit of business logic. I'm going to quickly hit a couple of slides, and then we'll jump right into a live demo. So what we're going to need is a .asmx extension or a web service file in our Visual Studio project. We'll need to annotate the method that we want to expose through a web service with web method annotation. We'll need the JSON feed, one that I showed you earlier, and this one is indeed publicly available. You're welcome to use it yourself. We'll need the Newtonsoft JSON library classes that are available to us, and we'll also need a little bit of business logic to say, if I search for oak, what is the correct genus, or the correct from all the genera being the plural of genus. Now, the genus that we associate with an oak tree is Quercus, but you'll notice that what we call an oak might have a different genera. So an oak leaf hydrangea is a shrub that's not a true oak, but it still has the word oak in it. So we have to have some way to distinguish between what a true genus is versus a genus for another name, another plant that happens to share the same common name. For that, we're going to need to use something called a dictionary, which is a collection in .NET. And the dictionary collection has a key and a value pair. The key has to be unique, which works out really well in our case, because the key is going to be the genus or the genera that comes back when we search for something like oak. And then the value does not have to be unique, so that's going to be a counter. It's going to say, okay, we have maybe 38 Quercus, 7 hydrangea, so on and so forth. So objective number 1 is going to be to read the JSON and then populate this dictionary with a counter of how many hydrangeas there were, how many Quercus there were, so on and so forth. Now, to populate the dictionary, we're going to need a bit of logic as well. We're going to first need to go to the dictionary and say, okay, I have the genus Quercus. Does this already exist in the dictionary? If it does, read the count, which here we have 38, increment it, in other words, add 1, and then store that new count inside. If it does not exist, then insert a new row and initialize it with a count of 1. After we go through that logic, after we've populated the dictionary, we're going to need to go through the dictionary one more time. We're going to need to iterate over it, find the key that's associated with the highest value, the highest count, and then we'll return that and say this is your matching genus. So without further ado, let's jump right in. I'll start with my existing project, and I've committed everything up to this point, so you can go out to GitHub and you'll be able to see the commit just for this. But I right-click, I'll tell you what, let's go down to the project level. Right-click and choose Add, and let's choose Web Service. If you don't see it here, go to New Item, and you'll get a longer list of options. So we'll say Web Service, and we'll call this Common to Latin. I was going to call it Common to Genus. Well, yeah, let's go ahead and call it Common to Genus. And we choose OK. Now, we need to give it a namespace, something that's unique. So for me, I'm going to give it plantplaces.com. And now the web method, this method that you see here with the web method annotation, this means this is going to be exposed as a web service. So let's just call this method convert common to genus. And I'll say string common. And then we'll need some kind of return value. So at this point, we're ready to do a bit of heavy lifting. Let's start by saying string return value equals no genus found. And then we'll return value down here. Okay, now we need to get to our JSON. And so for that, I covered a lot of this in a previous video, so I'll hit this a little bit quickly. If you're curious on how to read JSON, you can look in the playlist where this video is. You can find the video where I'm reading JSON. So first, we're going to say using, because we need a resource that's going to be closed. So we'll say using var web client equals new web client. Open curly, close curly. Inside of this, we'll say web client and then .download string. And here we need to put the JSON string that we had in our browser. So I'll go ahead and copy this, just like so. And I'm going to paste, and oops, I'll tell you what, I need to put that in quotes because it is going to be a string. One other thing, if you take a look at this JSON URL, you notice that the very last term is combined name equals oak, where that combined name can be any kind of genus, species, or common name. I'm going to delete oak off of there because you see we're getting the common name as an input to our web service here. So for that, I'm just going to, after the double quote, I'm going to do plus and then say common, just like so. And now we have our name. Now, one note: if you're getting a red line under web client, you may need to add a using statement to bring it in. So if you get a red line under web client, you'll see either a light bulb over here or one over here. Just click that and say import. Okay. Nonetheless, at this point, we have downloaded the JSON that contains that common name search, and we're going to save that into some raw data. So I'll say string raw data equals web client, so on and so forth, just like so. Okay, next we need to parse this. And the parsing is a bit interesting. That's where we use our Newtonsoft package. So I just want to show you how to get that if you haven't retrieved it yet. Right-click, Manage Nugget Packages, and then choose this Newtonsoft.json. It makes it really easy to be able to parse JSON. Now, the other thing that you need to consider if you're reading in JSON is you need a class structure that maps that JSON data that you're pulling in. I've already created that. I did that in a previous video, so I won't go through and repeat it just now. Just for the sake of time, I'll point you to that other video if you like. It's, again, on the same playlist where you'll see this video. So anyway, we'll say JSON convert, and then we're going to say deserialize object, okay? And the diamond operator, like so. Now, first of all, let's fix this JSON convert. It needs us to add a using for that Newtonsoft package. Again, if you don't see that statement, you probably didn't download the Nugget package. Now, part two, we need to tell it what series of objects to put this in. So Control-A, Control-C, Control-T, JSON viewer.stack.hu. We'll do a quick visualization here. You see we have an object. Object owns an array. Array owns a series of plants with ID, genus, species, cultivar, and common. So we have already written a class called plant that represents this collection here. And then this object right here. And then we have another object called plant collection, which contains a list of these plant objects. So as I said, did that in a previous video, but I'm pointing that out because here in the diamond operator, I need to reference that plant collection class and say, hey, JSON convert, I want you to take this JSON stream and I want you to put it into a plant collection object. So after that, we give it the raw data that we retrieved up above, which is just the raw parsed JSON data. Now, here's the cool part with this generic identifier here. What does deserialize object return? Well, it returns a plant collection, which is what we passed in is the generic identifier. So I'll tell you what, we'll say right up above this using statement, I'll say plant collection. We'll just declare the variable up here, and then down here we'll assign the variable. So plant collection equals JSON convert.deserialize object, just like so, and then we'll save. Okay, so now we still need to figure out this whole return value magic. We have our data right now. Our data is in this plant collection class, and we need to iterate over it, pull out the genus or the genera, and make our count. So let's do, I'll tell you what, let me put a few comments up here. So default return value, okay. Collection of plants from JSON. And then we'll say dictionary of genera and count. Again, genera is the plural form of genus. So dictionary, I'll tell you what we'll start. We'll say IDictionary, and then we'll give it a generic identifier for the key and the value. It'll be really simple here because the key is going to be a string, and the value is going to be simply an integer. We'll say int32. That'll work just fine. And then we'll say genera count equals new dictionary. And here we'll say, again, string and int32, just like so, open and close paren, and terminate semicolon. Okay, so that's going to be that table that I showed in the PowerPoint previously. Now, let's go to this thing called plant collection. And again, a class I made earlier, and I'm going to say .plants. Now that is the collection of plant objects that we received from this JSON convert. So what I'll do is I'll put this in a for each loop. Probably easiest if I do this in a few parts. So for each, and then we'll say plant. Notice the difference in capitalization. In, and then boom, just like so, plant collection.plants. Okay, open curly, close curly, give us our boundary for this for each loop. Now what we'll do is we'll say plant. Just remember a little bit real quick on the for each loop. This is a collection of plants we're iterating over, specifically this kind of attribute variable here. As we iterate over it, we're going to shake hands with every plant in the collection. When we're shaking hands with a plant, it's going to be in this variable called plant, and that represents an individual plant. So we'll say plant.genus, and that'll give us access to the genus. Okay, so now let's say if gener count, and then we'll say contains key plant.genus. So do we already have this genus in our collection? If it does, we'll do some magic there, else it does not have the genus. Actually, the else part is probably going to be a bit easier to kind of think about. Let's do the else part first. So genus does not exist, add it with a default value of 1. Or default count. Count is really a better option there, of 1. Okay, so we'll say gener count dot add, and then here we'll say plant dot genus, comma, and then 1. Notice the IntelliSense comes up and it helps us out here with the types that we're supposed to use. The genus is a string, and then the int value is a 1. The value makes sense to be an integer because we know we're going to be adding to this over time. So we initialize like so. Okay, so that's how we initialize. Now let's go back and consider the case where we already have that genus represented in our gener count. So gener count, and then square brackets, and we simply use our key, which is plant.genus. Now take a look at the IntelliSense that's coming up again. Because of the generica type we applied to this dictionary, you see it takes a string, it returns an int, which is perfect. So we'll say int current count equals gener count, plant.genus. And then we'll say current count plus plus. So we'll say add 1. Okay. And then we'll say put it back. Store new value. So we'll say gener count, and then we'll say again plant.genus. Then we'll use our assignment statement and we'll say current count. So very easy to do. Oh, almost got it there. There we go, like so. So at this point we have populated the gener count dictionary with the count of genus, for our returned result. So let me put a little bit more up here, a few more comments. We'll just say read the raw JSON data, okay? And then we'll say accumulate genera counts. Okay, and now we're going to say find the most common genus. Okay, so for this, again, a for each. And this one's going to be a little bit interesting because we're going to say gener count, and then we're going to say dot keys, just like so. So we're iterating over the keys, and the keys in our case are the genus, or the genera, if you will. Open curly, close curly, a little more work to do here. For each string genus in gener count dot key, dot keys, like so. Okay, now what we'll do is we'll say, before this we'll say int frequency. So this will be kind of like a frequency counter for our genus, and we'll initialize it to 0. Okay, and then we're going to say inside of our for each loop, we'll say frequency equals gener count, square bracket, genus. Okay, so what are we doing? We are using the key genus, we're finding out the count or the number that's associated with that, and we're putting it into frequency. But you know what? Let me do this in a couple different steps, actually, because we kind of need like an old frequency and a new frequency. So let's say int current frequency equals GeneraCount.genus. Now, why do we need old and new? Because we might be reading these in a different order, so we need like a high watermark frequency, essentially. So what we'll do is we'll say, you know what, even let's rename this. Let's call this high watermark. Okay, there we go. Make it a little more intuitive since that way. So we'll say if current frequency is greater than high watermark, then we have a new genus. I don't want to say a new genus, but a new top genus. So in other words, the one that has the highest count. I'm having a hard time finding words to describe that, but hopefully you know what I mean there. Okay, so a new top genus, a new highly frequent genus. So we'll say return value equals genus, like so. So we're assuming that this is the one that's going to be returned. And at the same note, we might not be through iterating because we have an if test which is in a loop. So there might be more genus that we need to consider. Think about the presentation we looked at just a moment ago where we saw a table like so, and you think the first time we go through, I'm not even going to bother to try to pronounce this one, but let's say the first time let's say Alloxylon is the first genus we shake hands with. Well, 1 is greater than 0, so that becomes our leading candidate for the correct genus for oak. But our second time through the iteration, we see that hydrangea is a 7, where Alloxylon is a 1. Now, hydrangea is the most likely candidate genus for oak. Now, we go through our loop a fourth time, and we see Quercus has 38, and we think that, okay, now that is the most likely genus for oak. So this is a process that might require several iterations. And for that reason, what we'll do is we will update this high watermark every time we elect a new genus. So let's change that, elect a new genus. That makes sense. Election, like kind of having a number of votes that we're counting. So what we'll do now is we'll say high watermark equals current frequency. Okay, so the next time around, if we're going from hydrangea to Quercus, then Quercus will be the return value. On the other hand, if we happen to read that list in reverse order, we started with Quercus at 38 and then we find hydrangea at 7. Well, because of this if test here, hydrangea would not replace Quercus because the high water mark would be 38 for Quercus and the frequency would be 7 for hydrangea. So at this point, we're in good shape to try it out. So let's have a look. Our web service is deployed now, and we can navigate around. You can see that VisualStudio.net was kind enough to generate some WSDL for us so that this can be consumed by another machine. And also we can try it out live, which is really cool. So this is our method that we annotated, convert common to genus. So I'm going to click on this, and I'll tell you what, the first time around we'll try it without the debugger, and I'll try maple. And maple should come back to acer. There are many plants called maple. The maple tree is the one that we're most common with, and that's the one that with the genus of acer. But there's also things like hedge maple, field maple, and other things that have a maple leaf that are maple-like leaf that are called maple that aren't truly a maple. So if our logic worked, this should come back as acer. So I choose invoke. We'll go ahead and tell the debugger to keep playing. And then we'll come back, and sure enough, you notice it comes back as acer, even though we know there are other things called maple that have other genera. So let's try this one more time, and this time we're going to debug through it, and we'll use our example of oak. So we choose oak, and I'm going to choose F10, and you see that our common name coming in is oak, and you see that it creates our variables plant collection, it initializes to null, our genera count, it gets our web client. Now we're going to get the raw data, and if you take a look at the string it's going to put together here, it's going to put together a URL with the combined name equals oak. So F10 over that. It'll take just a moment for that to get our data, and then one more time F10 will take that JSON data and we'll deserialize it from a string into objects. F10 covers that. We look at plant collection, and we see it has a collection of plants or a list of plants. If you look, there are about 63, so there are quite a few. Most of them will have the genus Quercus, but we know a few of them, especially the ones up towards the top, will have indeed a different genus. So one more time, let me just go here, and one more time over here, and we'll mouse over a couple of these up at the top. or we'll expand them if that works better. So that's the genus I don't want to pronounce or can't pronounce. We come down here and we say Casuarina. I'm going to guess that's what that's called. And hydrangea. So several different ones, but we know that Quercus is the most common. So now what we're doing is we're iterating over all 63 of those plants. And you see the first one, I'm going to guess Aloe Casuarina, and that's just a guess. The first one, it says, okay, do I have you? No, I don't. Okay, well then let's initialize this dictionary with that genus in a count of 1. Okay, so now we go around. The second one that we're going to see, similar situation, Alooxylon, or Alooxylon, I guess it is, and we initialize that with a count of 1 as well. I'll iterate through a little bit quicker as we go through a few of these. And let's see, what's this one here? This one, okay, we're still not down to one where we have a couple of genus, or a couple of specimens. So I fast forward a little bit. What's this one here? Catinus, okay, that one we don't have. I want to get one where we have a couple, at least 2 plants with the same genus. So we'll go through a few more. And what's this one here? Hydrangea. Okay, for hydrangea, it looks like the last time I went over this loop, it added the first hydrangea. Now we're going through and we're updating the count for that hydrangea. Note that the count is currently 1, but we're updating it to 2, and we're saving that count in our dictionary. Next time around, guess what? What do we have? Another hydrangea. So we're going to go through the same logic again where we get the current count, which is now 2, and now we're going to update it to 3. And now you see that's 3, and we update it to 3. And so on and so forth. Finally, we'll go back. I'll snap a breakpoint down here. And I'll tell you, we'll do it on our for each loop here. And let's go ahead and choose F5. When I choose F5, it's going to continue running until it hits the next breakpoint. So I choose F5. Now our dictionary is fully populated. And let's see, genera count. If I expand on this, we see Aloe-Casuarina, I'm going to say that that's what that is, has a count of 1. Alooxylon has a count of 1. Casuarina has a count of 2. Hydrangea has 8. And then Quercus has 45, and Willow has 2. So I anticipate that this next loop, which is looking for the highest count, is going to return Quercus. So I'm hitting it a little bit quickly here, but what we're going to see is, let's see, this has a count of 2, and the genus is Casuarina. So now the return value is Casuarina, and the high water mark goes from 1 to 2. And we keep going until we find something else that has a higher count than 2. So what's this one here? Hydrangea, okay. And what is the count for hydrangea? Hydrangea is 8. So now hydrangea is a return value. And we're going to keep going through this until or unless we find something that has a higher count than 8. So now we're here again, and what are we on? Quercus. Yes, we're on Quercus. What's the count of our Quercus? 45. Now we know from looking at a dictionary that's the highest ranked genus that we have. So sure enough, that's the one that gets returned. We choose F5, and it comes back and it tells us that Quercus is the most common genus for the common name oak. So nonetheless, we did this all in one method, and we did it in our ASMX class. In a real enterprise application, you probably would not put all of this logic in one method. A lot of this, like reading the JSON, should probably even be in a totally different class. Then we have a bit of business logic going on here. That should at the very least be in a different method. But nonetheless, for quick and dirty, we can see here how to read from a JSON stream and process it as part of a web service. And as an added bonus, we got to look at dictionary. So I hope this video has been helpful, and I look forward to reading your comments. Thank you.